Hello, everybody. Sorry for the slight delay. We're ready to start this week's Zooming, and we're going to start over on the other screen. And here we are. Chapter 2 deals with something called alkanes. And alkane is just a simple way of saying saturated hydrocarbons. And what does that mean? Saturated hydrocarbons. Well, saturated is a general word used quite a bit in chemistry. I think your first exposure was saturated solutions in Chemistry 1. And that context, the word saturated meant as much solute was dissolved as possible. Saturated hydrocarbons has nothing to do with solutions. It has to do with molecules that have only two elements. You guessed it, hydrogen and carbon. And the saturated reference here is there are as many as possible in terms of the number of hydrogens. Many H's as, oh, well, that's a sad typo, isn't it? As possible. Okay. So in all of these molecules, the absence of pi bonds means we have as many hydrogens as possible. You'll hear a lot of people talk about saturated hydrocarbons as defined as molecules that don't have pi bonds. The person giving you that definition is ignoring the word that they're defining. It's the consequence of having no pi bonds that gives you as many hydrogens as possible, which gives you saturated hydrocarbons. Anyway, I don't want to belabor the point. I believe I already have. Before the weekend, reminded you were responsible for knowing the names of the first 20 alkanes, and that going from methane to ethane to propane. I'm not going to list them all. To hexadecane, to heptadecane, to octadecane, to nonadecane, that's 19, and then icosane for 20. So I'm assuming you know all 20. If not, you're going to go to chapter 2 right at the beginning. They're all reviewed right there on one page. And I'm going to take it like you know what I'm talking about. I'm going to redraw these as stick figures. And numbering. And that means this is the 5-carbon one. The prefix pent in organic nomenclature always means 5. 5 carbons. The next one has 13 carbons. It has CH3 on the end and 11 CH2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And a 13th carbon on the end. 1 through 13. 2, 4, 6, 8, 10, 12. Got it right. And to say that, we need to end it with decane to show 10 carbons. And then whatever is extra ends up in front of that. And the prefix TRI, which you've had experience with in your inorganic nomenclature, also works here. Treat it like it's a foreign language, and that language says, okay, if I have more than 10, I have to end it with 10 and then say how much more ahead of time. French comes to mind. In French, 16 is 17 is hepta. I can't remember my French. There you go. So I won't even pretend. But in French, it's kind of reversed, but the same idea. You say the 7 and the 10. Sad Canadian admission there. Okay, this one is goofy, but it's perfectly fine. There's 4 carbons going this way and then a CH3. So let's draw that. CH3 at the end, then 4 carbons. 1, 2, 3, 4. Comes up to the CH2 in the middle. Goes down to a CH2 in the box again. And 4 more carbons than the CH3. So 1, 2, 3, 4, and then CH3. So there should be 5 carbons in blue on each side and the CH2 in the middle. And that should be 9. I'm gonna go 1, and then 3, 5, 7, 2, 3, 4, 5. Did I say 9? That was goofy. 7, 8, 9, 10, 11. Yeah, 5 times 2 is 10, not 8. Okay, and we say 1 plus 10, undecane. Our last example is already in stick figures for us. We should always be trying to get better and better with stick figures. Don't ever say, no, I don't want to spend the time doing that and redrawing that. Please spend that time. You'll get better, and it will save you much time on exams. So I'm going to count by twos. 3, 5, 7, 9, 11, 13, 15, 17, 18. Prefix for 8 is octa, and we end it with 10. So that is the first part of naming hydrocarbons. We have to come up with the longest chain's name. Now, it's very common for the longest chain to have groups on it. So let's put a little divider here. And you learned the name of 20 hydrocarbon chains. So let's copy one of our chains. We got the 5 carbon chain. And we already know that's pentane. Now, pentane might have an extra carbon sticking off here. There's 2 ways to number this chain, and only one of them's correct. There's the red way and the green way. The names would be in red, it would be 2, and a 1 carbon group, this black carbon here, is called a methyl. Not methane. Methane would be a chain. That's easy to remember. Methyl is a group. Okay. That's supposed to be a D. I don't know what that's supposed to be. There we go. So in effect, we just learned the name of 20 groups. Yeah. Methyl, ethyl, propyl, butyl. Just change the ANE end to a YL. And the green naming is not as good, so I'm going to cross it off. 3-methyl pentane would be the name. And there's a rule why that one's no good. And the rule states this. If you have a group in a molecule, you must number it in the direction that puts the group on the lowest possible number. So chains can always be numbered in 2 directions. If one of the direction gives a lower number for the location of the group, the red 2 is a lot lower than the green 4 starting from the other end. So there you have it. Let's do one more simple one with a different group before we start putting more than one group on there.
Hey, Professor.
Yes.
Why did you put a 3 there on the green next to the 2-methyl pentane? Was that supposed to be a 4?
Did I miscount? Goes 1 to 5 green this way and 1 to 5 red this way. I'm just numbering the chain in order.
No, I mean next to it, where you said methyl
Oh,
pentane.
why not a 4? Yeah, because I wasn't watching. That's a good question. I'm sorry. Yeah.
All right, no problem.
No,
I
no,
missed
no.
that.
Yep, no, it was very misleading what I was doing there. Yeah, the green method put the 4 with the methyl, didn't it? And for the same reason, that's not as good. 4 is a higher number than 2.
Okay.
Yeah, I did not have a methyl over here, and my name said I did, and I lied, and I don't like lying. Nobody does. Okay, so now we have a new example, 2, 4, 6, 8, 10. So the name will end with decane. We'll put a group on, and we'll put the numbering in the appropriate spot. If I put this group over here, and then I'll put another group, say I put it on the 4th carbon, the 3rd carbon on this one. And I'll put another group here. Oh, we're going to jump some steps because I know you were reading on the weekend. So we got 3 groups, and 2 of them are the same. We have this group here. Let's copy my molecule. A lot going on here. Now, when you have multiple groups, the rule stays the same. Your choices of numbering are left to right would give your first group on 3. And we'll do the reds being correct all day here. The red method puts a group on 3, a group on 4. I can't draw a 3 apparently. And let's not, today seems like a day I might be miscounting a lot. 3, 4, 5, 6, 7. And we're ending with 10. And the green method, your first group isn't encountered until carbon 4. So green is wrong. The red method has a group on 3. 3 is a lower number than 4. It doesn't matter what the group is, it's number that tells you the correct direction. So we have our decane, and here's our decane, and we have groups that are called, let's see, we have a 2-carbon group. 2-carbon group, with the highlighter. 2 here and 2 there. That's not a methyl group, that is an ethyl group. And down here we have a 1-carbon group. That's a methyl group. Once again, we have an ethyl there and an ethyl there. Now the question is, in the name, where do we list the groups? That's an easy answer. The groups are listed alphabetically. E is before M in the alphabet. So this is not our final answer, but we're going to have ethyl before methyl. I left a little room. Okay, so far we got the groups alphabetical. And really, there's not just one ethyl. There's 2. So we're going to put a diethyl, purple. There's an ethyl on 4 and an ethyl on 7. The name must tell me that. So if there's a di prefix in front of a group name, guess how many numbers are going in front? You guessed it, 2 numbers. 4,7-diethyl. There's only 1 methyl, it needs a number, and it's on carbon 3. And that is the correct name. Don't use the green numbering. It has the first group on a higher number than 3. All right, before we move on to a new one, this whole page here, we could easily figure out the formulas for every molecule, either from the picture or the name. All right, so formulas for hydrocarbons, if you look at them very carefully, every carbon in a chain has at least 2 H's, and the ones on the end have 3. Just stick figures, and carbon always has 4 bonds. So it's always 2 times the number of carbons plus 2. So translation, CnH2n plus 2. For saturated acyclic, oh, I threw a new word at you there. Saturated acyclic hydrocarbons. We'll talk about what happens to the formula when we have cycles. They're called rings. So we'll close up this segment of the lecture with formulas. When we have 5 carbons like pentane, you don't have to count all the H's here to figure out it's 12. You do 2 times 5, because that's the number of carbons, plus 2. And that's 2 times 5 is 10, plus 2 is 12. So we'll put the formulas in pink. And here they are. C5H12, tridecane, C13, 2 times 13, 26 plus 2, 28. Undecane, C11, H22 plus 2, 24. Octadecane, H36 plus 2, 38. This one I'm going to go from just the name, 2-methylpentane. Methyl is 1. Pentane is 5. These are carbons. C6, C6H14. 2 times 6 plus 2. This one over here, I'm going to go from the name. The name's actually easier than the picture. And you're saying to yourself, wait, there's not 2 H's on this middle carbon. Wait, stop. Well, when you put a group on there, you cut the number of H's down by 1 here from 2N, 2 H's to 1, and you added 1 up here when you put the CH3. So that formula works even if there's what we call branches in the molecule. CnH2n plus 2 works for every saturated acyclic hydrocarbon. So down here we have a name which tells us the number of carbons. We love that. Don't forget there are 2 ethyls. And each ethyl has 2 carbons. And a methyl and a decane. So 4, 5, 15, C15, H32. And that brings to a close our introductory segment on nomenclature. And we will pick it up in 5 minutes with many more examples. All nomenclature for most of today. So stopping my share. And I'll see you in about 5 minutes.